Hello, welcome back. So today we talk about the complex number. Okay, so complex number is in terms of real number and imaginary number. So imaginary number is set -1. Okay, so I'm going to start writing it. Let's say I have a symbol I define as A, B, and Z. So I have to say that my Z is equal to A plus B times I. So it's okay that you want to reverse it, like let's say A plus I times B is still the same. But sometimes syllabus will using J times B. Okay, so even you type J, you think, is it correct if I type J? Yes, it's correct. But MATLAB is recognize it as I because it fixes it using I, it stands for the square root of -1. So that's why even you type J is in the MATLAB it records as I, but it's still the same thing. Okay. And for MATLAB, it can do the calculation on the complex number, whether you want to find the conjugate, multiply, minus. It's still very simple. It's very useful to find. Let's go ahead. Let's say I'm going to use like reciprocal. Reciprocal is equal to 1 over z. So I get in this number, but MATLAB has a good thing that if you want to make it like, you're gonna make it like the thing in bringing it on top, then by normally what we learned, we have to times the conjugate, which is A minus BI, A minus BI. We have to times the conjugate. And we shall get 1 times this thing, still the same. Whereby the below is A times A is A squared, plus minus that cancel out, so become minus B squared times I squared. So I squared is because I itself is equal to square root of -1. So I squared is equal to -1. So here it become -1, negative become positive. So become A minus BI over A squared plus B squared. And because for manual calculation, we have to take some time to calculate. But MATLAB is very simple, it's very cool, that you just click collect. This is a command. Okay, collect of this, I think, reciprocal, enter. So it will show in that tone. So not looking nice, I can say pretty, answer like this. So as you can see, A minus BI, A minus BI here, and A squared plus B squared, A squared plus B squared. So it's very convenient when you want to do the calculation. Okay. Next thing, I'm going to define my another complex number is equal to 3 plus 4 times I. Okay. So when you have given a complex number, I put real to collect the real number of this complex number, which is 3 here, and then press the command img imaginary of the complex number, which is 4. And I can find the conjugate as well, conjugate of the. So you can see 3 plus 4 become 3 minus 4i. This is the conjugate. All right, cool. And next, we also can find the angle. Let's say angle of Z2 is equal to angle bracket Z2. So angle is the command. This is the complex number I define. All right, then can get the answer in terms of the radian mode. Okay. And next thing, we're going to plot a graph for this. Let's say conjugate Z minus 3, whether is smaller or equal to 2 times Z plus 3. This thing. So if you know that Z, let's say I define Z is in terms of X plus yi, then I can plot the graph like this. One is in terms of X, is in terms of real number. This is the X-axis. Y-axis I put in terms of the imaginary number. And when we have something modulus, actually we can say it's Z squared and the square root of it. It means that we have something, square root of both sides. Or simply, I can bring it square on both sides. So when I square both sides, I got two numbers being square. In the end, I will result a shape like a circle or an ellipse, something like this. So we go ahead to try to plot this graph without ourselves to plot it using the MATLAB. Okay, so go ahead to define the two variables I want, which is x and y. Then I say my complex number z is x plus y times I. So I got my complex number, and then I go ahead to type this equation. So equation is equal to the modulus we use ABS means for absolute z minus, I want the 3 into the exact form, so same 3. Okay, and I put here is equal sign because it's greater or equal, I put equal here. 2 times absolute, I did this, z plus our exact number, which is 3. Okay, there we go ahead. One bracket sum. Okay, got this equation. Alright. And if we want to plot a circle ellipse, then we use f implicit of my equation. Okay. As you can see now, it is not something look like an ellipse because here the range is not today. So I can zoom up, or bring it over here until -9 to -1. So I can define my range of it. I can make it larger. So let's say from -10, x-axis -10 to 0, and y-axis is from -3 to 6. All right. Okay. And we say f implicit, my equation. My range is from -10 to 0 for x, and then for y, it is -3 to 6, for example. Right. Still not the perfect shape, so I can make it larger, become -5 to -5. Okay, there we go. Hey, implicit equation, put it -10, 0, and -5 to 6. So right now it looks nice shape, as you can see. Okay, cool. So next we go back to our code. And you can try yourself to plot a graph. Let's say, to get an example, you can pause the video a while and try it out. Z plus 3 modulus plus Z plus 1 modulus is equal to 4. You can pause it up before trying to do this. Right, so clear all thing here. So start from scratch. So you have to define your x and y. If you can put a and b, up to you. When I try a and b, okay, this is the same thing. So z is equal to a plus b times I. So I define my complex number in terms of a and b. Okay, if I want to make it nicer, you can assume it's optional. Even without it, it's all correct. It's real. Yeah, assume a is real. Or you can assume that b is also a real number. But this is optional. If you don't put it, it's also correct as well. Okay. Then I'm going to type in my equation. It's equal to absolute z plus symmetry bracket plus absolute z plus 1 z plus 1, and it's equal to 4. Okay. And remember, equal sign, we put double equal. The equal here means we assign this function, we store this number into the equation variable. Okay, we have our equation, then we put f implicit equation, then I put a range, -5 to 5, this is x, -5 to 5, this is y. Okay. Right now you can see, it might come up some image of this. Okay, all right, so that's all for this lesson. Okay.